Hello, everybody. So, got a couple things to go over this evening. Let's see, what's the list look like? So there was one issue from probability that last week when we were talking about that, I kind of made a big deal about that and wrote something wrong on the board. It was obviously wrong when we looked at it, and asked you to think about that because that's sort of the most common thing we'll face when debugging probability issues. Simple probability is straightforward. That's easy. It can be in code. But when they start to get a little complicated, I wanted to explicitly pause and look at the thing that's most likely to give us the most trouble. So that's what that was about. So hopefully you thought about that. And if you were busy and didn't think about it, we'll kind of see the solution on that tonight. Then some other things that have kind of shown up in the homework for tonight, or shown up in the homework I wanted to quickly talk about those and sort of generalize them beyond just Unity and C#, because this class is not called Unity, making games in Unity or coding games in C#. So some of the things that are like C# specific terminology, I wanted to make sure and talk about how those generalize, which are very short points. So then we will get into examples this evening. I have a couple things in mind. The one that's actually pulled up on digging through some of my old games, the one that's pulled up on my Chromebook right now to look over if I need a reference while we do it is a NavMeshAgent. Because one of the things on our major learning objectives mentions AI, but it does it in a very vague way. I think I was at the meeting. I don't know why I just said they. I was at the meeting where those things were set up. Those major learning objectives were set up, but I think what was going on there was more about enemy AI. But NavMeshAgents are a really, really useful way to have our character move around a game. So we were looking. That's my first thought on our in-class example. But some talking things first. So the first off is one that's going to be what seems like one of the most common issues to show up around probability when debugging stuff. Probability always seems like such a mess in math class. Right? We have that messy notation, and that was the main reason I wanted to go over that last week. Is if you ever have to go look stuff up, you're going to see the formal math notation. But probability and statistics themselves, when you get past all the complicated math class notational stuff, that's really how humans process. So the idea of it comes naturally to us. Like in statistics, we all know about that, the bell curve. There really are averages in the world. So, and we go through all sorts of notation, use Greek letters and stuff, but really this relates directly how humans think all the way to the instinctual level, right? When we have like a newborn baby, there's that narrow range of things that look like that baby's mother. And that's how the baby knows it can trust him. And as we grow, that range expands more and more, and things get the human will start trusting things that look less like its own mother. So probability and statistics, beyond the math class notation, is very instinctual to humans. So when we're doing simple probabilities, like just the chance of, like simple probabilities are very, very straightforward to go. But when we start to get to more interesting situations, the compounding our probabilities, that's where we sometimes hit problems with debugging. And what I've noticed over the years, I tried to summarize last week. I had that example. We flipped a coin twice, and there's a very short list of options we could get, right? Flip a coin twice, it's either going to be heads or tails. So there's only 4 possibilities of what we could get from those 2 combinations overall. And I asked the question, the probabilities are both the same. Both the same. And then I kind of worded that as both heads and both tails, which is actually where the problem originates. Then when we did this in class, we went straight from that question to the math notation. Both heads, so I wrote it like this, and there's usually our intersection symbol in mathematics, and both tails comes down, and I wrote it like this, and well, we have an and probability, so add the ors, multiply the ands. Two heads shows up 1 out of 4 times. Multiply the ands, and two tails shows up 1 out of 4 times. And when we punch the numbers in, we get 1/16 from that, which, well, we can look at our complete collection and tell that that something went wrong there. And what actually went wrong there is this question. What should that question be? Any thoughts? Everybody's quite sure. So this is the thing I found over the years that shows up the most when debugging compound probabilities is this should be an or question. What's the probability we get both heads or get both tails? Because that completely changes our notation here, right? The probability of 2 heads is still 1 out of 4, and the probability of 2 tails is again 1 out of 4, but we want to add the ors and get 2 out of 4 or 1/2, which is what we would actually get if we look at our entire list and count. So over the years, that's what I found to be the most problematic is we're used to plugging in equations and setting things up. But when we're preparing, getting things prepared, especially on complicated situations, in language, which is the way we're probably thinking about them, we get a little sloppy with our words sometimes. So whenever you set up compound probabilities like that, and then run your program and something, if it doesn't seem to be working right and you're not sure why, if you have some of these compound probabilities, the first thing to check I found is often come back to the original question and try rewording that several different ways. That can give us ways to check things. There's a logical check. I always show it in the intro classes, but some people might not be quite as familiar with that. Anytime we have logic, we have our logical statement where some premise implies some conclusion. We can manipulate that. There's different ways. What's a good one? I don't know. The one I always use is it's raining, implies need an umbrella, or something along those lines. And whenever we need to debug something like that, a lot of times it's how we originally thought about the question. So it becomes an English problem. Something we can always do with logic is we can negate things. So if we can negate both of those, say it's not raining, that would imply the negation of this. Not need umbrella. Which I ran out of room there. But that statement's not as true as the first one, right? We need some more details. Raining isn't the only reason we would need an umbrella. Maybe you're doing a cosplay as the penguin from Batman. And in that case, a penguin costume should definitely include an umbrella, no matter what the weather's doing. So if we negate both parts of a logical statement, we should get something we don't have enough details for. We can also switch orders. So if we negate and switch the order, we get back to what's called the contrapositive. So negate our original conclusion that we don't need an umbrella, which I'm going to run out of room here, so I'll abbreviate that. Don't need an umbrella would imply the negation of our original premise, which would be not raining. So this is someplace where complicated compounding logic will show up when we're working with the compound intersection of probabilities, right? Like, where's our character standing at? What's the current hit points and magic points and stamina versus everything else happening in the game, and the probabilities of an attack against our armor. And it can build up to some compound situations fairly quickly. So this traditional logic check, which goes way beyond computing, this always works. Math, English, philosophy, anytime you have logical statements that follow things like this, if you negate them, you should get something that you do not have enough details for. And if you negate them and switch the order, you should end up with something that has the same truth value as your original statement. So what I found is sometimes those compound probabilities will cause bugs in the code, and beyond just the little typos, because that can be a mess to code in. But once we get past the typos, the logic can fall apart on us because of the sloppiness in our English version of planning those things. So keep in mind, a good thing to check is to come back to the original plan on those compound statements and try rephrasing that several different ways, such as the nice structured converse and contrapositive way. And that as a way to confirm that your original phrasing of the problem before it went into math notation or into math formula was correct. I just wanted to talk about that one because that is something that I found to be a very, very common issue, because we usually have a lot of things going on in a game and they're all going to affect each other. So we want to keep in mind those checks on our plan, ways to confirm things. And a lot of times it's not just the code, it's actually stepping back and reevaluating how we phrased our original design. Could have led to something easily misconstrued. Okay. But yeah. Any questions about that? That's just a tip I found over the years, a place that's really, really easy to get off. So I thought I would share that with y'all. Okay, I assume the silence means no questions. So the rest of the stuff tonight is pretty much going to be things about Unity. So I'll go ahead and pull up Unity. So over the weekend, there was, I reworked the, whatever this week's homework assignment is going through all the steps, making sure they were valid, and took note of a few things that might need addressed as we go through here. One of the biggest ones is the book was apparently written before fall of 2019, because in fall of 2019, they made a big change in Unity, and that before that, if we inserted a rigid body component to a game object, we automatically got a collider with it. Then they made a lot of improvements for colliders, and automatically doing a collider didn't quite work out so well. Close curtain, sun's coming back out. A few minutes ago, it looked like the sun wasn't going to be out this evening. So anytime the instructions in the textbook say to add a rigid body, go ahead and assume that you need a collider as well. Also, I was expecting an error that didn't happen. It happens sometimes, but not every time. That's I'll just go ahead and talk about it. The way our book says to name the scenes with the starting with an underscore. When they put Unity together, that was an organizational thing they used that listed out alternatives. So like underscore scene 0 is would be the alternate version of scene 0. So sometimes it won't open by default. I know there was a question last week and we set up the discussion board where y'all can share your work with each other. If you open up somebody else's project and go through all the version control things, and then you go open it up and you see a completely empty scene, this it's happened quite a bit when they're grading y'all's homework already. If you're looking at a completely empty scene instead of something there, but you know they made the game, go into the scenes folder and just select that scene to open it, because the Unity engine, if you start with an underscore, will interpret that to be the alternate version of the scene, not the actual scene. So, it doesn't always open by default. And y'all have seen brand new Unity projects, right? We have that big open space with nothing but a light and a camera there. So if you're looking at that, but you know there should be something in the game, just go in scenes and open that. I was expecting that bug to happen here. I thought I had everything set up so that it would definitely happen, but then it opened fine. So I guess first off, you'll notice that graphics, not the spaceship one you had. The same code works with other graphics. If I go ahead and run this, so I replaced the spaceship with a little dragon animation from the 148 class. This was from our in-class example. And then I just made the sphere a semi-hollow thing to look like smoke. It just rotates around him, and replace those other things that we're shooting with these the other stuff. But the exact same code runs the game fine. Oh, and I switched to a fireball, and because that seemed to fit a flying dragon thing. But essentially the same code worked, and then I modified it a little to fit this. So I wasn't really hitting any bugs, but I also wanted to point out, if you want to change the images around and make little modifications to the game as you're going through it, feel free to do that. Your homework does not have to be an exact copy. Right? It's not an auto-graded thing by a computer. A computer is not comparing your code to some baseline model, like you might have seen in the classes doing Python stuff the past few semesters. I'm actually grading that. I'm reading through your code, looking at what it does and running the game and all of that stuff. So changes are fine. So what's in the textbook is a baseline model, and this stuff takes practice. So if you want to extend beyond that and customize it and do a little bit of practice, that is perfectly fine. Maybe make a list somewhere that says list out the changes you made. Yeah, there's different takes on that. Different people approach languages differently. Past few semesters, Python's been with the or the Python in the SDEV 120 and the SDEV 140 class, because it's showing up all over the place now, has been straight out of the Cengage textbook, which auto grades it. And Cengage does that thing to counter out the sites like Chegg, where you can just go Google the answer for any question. If you pay them $14.95 a month, you have the answers to every question. People like copy and paste that. So to stay one step ahead, Cengage actually parses through the Python code, make sure you named your variables a certain way and put things in a specific order. So if every time they update the answer on sites like that, Cengage can just change the question. So those sites, those copy and paste sites, in particular the paid for ones, which originally had a great purpose. That was supposed to be a tutorial, because Chegg used to be a bookstore, but when bookstores faded out, they tried to add tutorial service to the bookstore, but so many people just scroll to the bottom and skip the whole explanation part and just copy and paste the answer. The people that would use that as a valid resource, the whole explanation part, tend to not use it because they don't want to be grouped with the people that just copy and paste the answer. So it ends up being just really just one, for the most part, one group of people that does that. And that was their solution to stay one step ahead, is the auto-graded stuff as dynamic questions that will change very, very rapidly every time those sites update the answer they have written there. I see some drawbacks to doing it that way, like requiring everybody to name their variables the exact same thing and write it in the exact same order, and having the grading comparison actually parse through the code instead of just look at the results. But that's a different point. That's not how these are being graded. I'm reading your code, making sense of what's going on there. And yeah, with those, like I just said, it's okay to change those graphics. If you need to make some modifications to fit that, that will be fine as well. There was a lot of stuff thrown in there, and sometimes they would just show little segments the way the textbook did it. So there was easy things to overlook. I only encountered one thing that I thought was really a problem. Where were my notes? And it wasn't the problem I was looking for, or the problem Tyler mentioned before class, because he had to go to work. I think I put the notes in here. Yeah. Took me like 4 tries to remember to put .txt at the end of that file. I kept saving it as just an arbitrary file that with no extension. At the end of the bounds check thing, it reset the variable that would it then turned around and checked to see if that was ready to, if the things were ready to need to be removed. So open that. We get to the very end of the bounds check. It reset that variable. So up here, it turned that on. It set that to false if things were off the screen, and then reset the variable, which this is in late update. So this is the very last thing to happen in the frame. So then whenever, like say, one of these objects checked that, it would have been reset by the time this runs in the next frame. So I did comment out that I thought that was an actual, that was the only actual problem I hit, but it wasn't related to the problem I was actually looking for. But the code works in other things. So I wanted to look at a few of the things they did in here and kind of generalize those before we jump into our our Unity example, because obviously the book doesn't cover everything, and there's some really useful ones, other really useful things that we could see that I thought we could go over instead of just doing the same thing the textbook does. So this one, our textbook here likes to use singletons for some of our objects. A singleton is a C# specific thing. That means there's one and only one copy, which might sound familiar from some of your work in other languages. So I wanted to make sure and specify this because that's a C# specific thing using singletons. But when you go and after we finish this class and you start looking into other game engines, see which ones you like the best, and using different languages. I mean, if it's something we can deal with a slower language, Python's obviously a lot easier to code in, or maybe you just like Java more than C# because it's not a Microsoft thing, and some people just really dislike Microsoft, so, which makes them not want to use C#. Or you want to go back to pure C++, in which case that C# thing called a singleton, well, that's not what we call it in the other languages. What it means is there's one and only one copy. So I mentioned Java. If anybody's had a Java class, you might recognize that one and only one copy. That's what static means. Even in C#, we have to make something static before we can make it a copy. And that's the big difference here. If I share my screen again. We have a public class, and then we create a static instance of that class in C#. But in Java, we would actually do a public static class. When we set it up. And then we can only ever make one and only one instance of that. But the same, so that's where that concept would apply. So if you go to like JMonkey and said you rather work in Java and open up JMonkey to make your stuff instead of Unity, you'll find a lot of features are the same. But that thing we saw in our homework called a singleton isn't available in Java. Because instead of making a public class static, a particular instance of it static, we actually make our entire class static in Java so that we can never make multiple instances of it. We only have that one and only one copy, which means anytime we use it, there's only one copy. We can look at the class, the design for it, rather than a particular instance of it. Similar thing in Python. There's different ways. The easiest way to do that in Python, it would be don't use class notation. Instead of designing the class and creating an instance of it, in Python, just dedicate an entire script, one .py file to that thing. So you just put your variables in there, put all your functions in there, and then when you get over to your main script, you import that, and no matter how many times you ask for it, you didn't create a separate instance. You imported that one instance, so you're always referring back to that module, is the term we use in Python. But there's one and only one version of that. C++, there's different tricks. What I like to do is use a pointer. So after we set up our class, I guess in this week's example, the singleton was the player object itself. There's also a singleton for the camera. And then we were able to refer to those by data type instead of reference name to a particular instance of that class. In C++, whenever I need that, I use pointers. So if the type was player, use a pointer to the player, and that way, instead of an instance of it, we're pointing at a particular spot in memory, so that anything else that would be like the player would point to that same spot in memory. Not quite the same as static, but that's how I usually handle that. It makes the most sense in my mind. So we'll see it in C# as a singleton, which all of these languages are older than C#. So this was one of those things that they were able to look at the older languages and make an improvement when they did that. So the singleton's a nice way to do it, but we call it something different in other classes. So, or languages. So whichever language you're working in, keep in mind that there's some things we don't want to make sure there's always only one copy of. We don't need multiple player objects. We don't need multiple camera objects. Right? We only need the one, and when there's one and only one, we have some advantages of those things being static. Multi-scenes. Also put multi-scenes on here, and I'm not sure why I put multiple scenes on here. I'll talk about multiple scenes. Maybe I was going to be about moving through them. So maybe we have two scenes. I'll make a new one in this real quick just to show how to do that. Create a new scene. There it is. So again, there's multiple ways to do it, but we'll create a new scene so we have more than one. I'll call this the cut scene. Maybe if I had two things with underscores, it'll do something. So when we go in here and work on this, then I inherit other stuff. I'll just stick an instance of the dragon there for a few seconds. Oh, whoops. We're in the models. Which one's the model? I think that's the model. Yeah. I'll just bring in the model. The animation should work. If I play it, a little cut scene, let me rotate that so we're looking at a better angle there. If we play it, we see it. Oh, the animation is not working. Oh, I know why. Do need the animator controller for it at least. Nope, something's not working there, but why is that not animating? Oh, where did I just put that animator controller? That's why. Oh, apparently I didn't put that in there. Let me try this again. So whenever we have animations, we need a controller to work with those. So if we go in to edit that, it should just automatically start playing that animation when we go into it. There we go. Once we attach that, the animation's built into the model. So once we attach that, we see the thing, and probably need a way to get to our next script. So I'll just, or our next scene. So I'll quickly make that, because I wrote these notes last week and I'm not really sure why I wrote multiple scenes on there. So might as well kind of go over that. Add control component, and I'll just do something called next scene. That doesn't exist, so instead of searching for it, we can just automatically create a new script with it and make a new component. Which is another thing that should probably be on my list here. There's a library that has already shown up in the homework, the scene management. So using the Unity engine.scene management library, we can create an instance of the scene manager and then jump to another scene, like maybe after a certain time interval or something. Or anything special, I'll just do it as a method. So for a cut scene, I'll skip this and make a new method, because that's another one to make sure and talk about what it's doing. I'll make a public method, void, which you've often heard means doesn't return anything, but void is a type. That is a data type, right? It'd take a lot to see it in C#. I'll do it. I think everybody's seen Python, so I'll just do a quick example in Python to show that it is a data type. So if we just have like a function that writes hello world, a void function, it doesn't return anything, right? So if we say x is say hi, runs that function. If we print x, we get none. Or a better way might be to print that function. So it runs the function and then gets to the end and returns. And in Python, it's none, but it is an actual data type. So y'all probably saw that in Python, that none is a particular type of data that we have to pass around sometimes. Same thing with when we say void, that is explicitly the type of data we're returning. Next scene, we'll just have a method that goes there, and we can call scene manager dot I'm suddenly drawing a blank. What is the word I need? Probably in this example I have pulled up. If I can find it, is instead of simplifying the example, I just opened this big complicated role-playing game to look at. Inventories, items, maps, it's probably there. Nope, it is not. Maybe it's under player. Oh, load scene. I don't know why. That's what it is. So the scene manager has a built-in method called load scene. And then we just have to pass in the name of the string we want to go to. So I called this, the next scene was called scene 0. Underscore scene 0. The thumbnails are in my way. So that's the instruction, go to the next scene, and maybe just a delay. And our textbook used this a couple times, and I don't remember seeing them actually explain what it is. So you're probably used to just calling a function when we want that, right? We just call that next scene method. But sometimes we might want to wait on that. Right? We don't want that to happen right now, but we have a pretty good idea of when we want it to happen. So an alternative method to call these, another one of these things that comes because C# is so much newer than those other common languages. So they were able to look at some of the things that seem to be lacking, is we have this method invoke, which is just an alternative way to call a function. And we pass the function name in as a string, and then insert some sort of delay, like 3.5 seconds. So that is attached to our Dragon object. So when we start playing this scene, it should jump to the other one. Oh, no. And there's that error message. Scene 0 couldn't be loaded because it hasn't been added to the build settings. So whenever we go to build a game, I was reading that from the bottom. I guess I could have pulled it up here. It hasn't been added to the build settings, which is the manifest. Unity handles all of that for us. It writes the manifest. And for those who haven't encountered that before, setting up packaging, how we package our code, one of the most important things is the program manifest, which, just like the traditional usage of that word for ships, right? The ship manifest is the list that the captain keeps of everything that's on his boat and why it is on his boat. We need the same thing when we have lots of different pieces of software interacting together. You'll have probably noticed by now how big the Unity projects are. So if we go to File and Build Settings, which on a Mac, it might be under the Apple menu. Build Settings might be one of the under the Apple menu, but it's either File or the Apple menu, but I can't remember which one it is in the Mac. My Mac's all the way in the other room. So here are the scenes that our manifest knows about. So it actually doesn't know about any yet. And we have this button to add the open scene. So that gives us our cut scene. And notice a 0 over here. Now, if I go back to the other scene and once again come to the File menu, or I think this one's under the Apple menu, can add the open scene, and now it knows about both of them. And notice the index on them. That makes a difference. There's no, I can't really edit it. Right click, I can turn it off and remove it from the list. But this, because of the order I added them in, defines the index. So if they go in the wrong order, you'll want to remove them and make sure you put them in the right order. Now when we play our game, we were looking at scene 0, which should come after our initial cut scene. So it started immediately. If we go back to our other scene and run this, hopefully it'll jump to the other one after 3.5 seconds. There we go. So that's how we set up a cut scene, and then the scene manager will jump between them and make sure they are included in the package manifest, which is all handled in the background. So we don't have to worry about anything, but we do need to explicitly say, include this scene, include that scene. We do have to say which ones we want. And then to jump between them is, well, that should look familiar from how the textbook has you restart the games, right? I think it showed up in the apple picker game and the space shoot 'em up. If something goes wrong, the player loses, we're going to restart the level. We just use scene manager to load the same scene. I'm not sure why I put it on my to-do list. I just went through the basic process and I can't quite remember it. But the invoke thing is really, really nice because a lot of times the spot where that makes the most sense to put in our code, like in this situation, that we're going to run a cutscene for 3.5 seconds of the dragon flapping its wings, and then get into the spot where the dragon burns down villages and stuff. We need that 3.5 seconds. So we could set up a big complicated timer, or it's already built into this to just don't call that method right now, call that method 3.5 seconds from now. Make sure and explain what that was doing there in there, and make sure you use the reference name. It involves hashing. So we want to turn that into a string so that it gets hashed and turned into that. Which I guess leads to another point I wanted to make. I don't think I have the apple picker game on here. This was one from last week. Yeah, today was a really fun day in the SF120 class. We've gone over logic gates, and it was the day where questions led into like material science stuff and how does silicon do that, and the chemistry of doping with phosphorus or potassium and how we make that, and answering a whole bunch of those curiosities. That's always a fun day in that SF120 class. And yeah, like actually seeing the switches, how switches make that stuff. Was this our example from last week? Okay, yeah, that was our example from last week. I'll just pull up the book because you all have seen that. But next thing I wanted to point out. And that is saving small bits of data. It definitely showed up in the apple picker game with the high score. I believe that's how we saved the high score, right? With the player preferences. I wanted to make a note about that. I'll go in the book and find that in the code. Because our book just said, yeah, you type this code and then that will store the value for the next time the game runs, but it doesn't really tell you what that's doing. Last time I taught Java class, or the last 2 times I taught the Java class, I know I included hashing, but I can't remember if that was in the actual, the stuff that has to be taught in the course, or just something that I added in, because it's like, oh yeah, they should probably see this. So somewhere in our game here, does anybody remember where the high score was? I do Control F.
I actually have the game pulled up. Give me a second.
Oh, that'll work.
It's in basket.
The player preferences. Oh, do you have your code pulled up? I'll just point at your code instead of looking here.
Okay.
If you can share your screen.
You had to unshare, I guess.
Oh. Yeah, I thought I had a version of it. So we have those player preferences where we keep that, right?
So here's the high score thing.
Oh, okay. So that's where we're setting it. Oh yeah, I wrote it over here. And it looks like something that already exists, right? Because you didn't import it. Where's my low pen? Oh, that's in the way. Move this out of the way, because here, well, we start our code, come down, and suddenly referring to this player prefs or player preferences, like it already exists, which apparently it does, and we keep using it. And obviously your code didn't crash here, so that's got to be something that exists. And what it is, I wrote the technical term down, the one we never say. That is a hashed jump table, which is quite a mouthful. For those who have seen Python before, it's basically a dictionary. In Java, we call them maps. We have different terms for them. In PHP, we call them associative arrays. We have different terms for them, but those that we use, the dictionaries in Python, the maps in Java, the associative arrays in PHP, those actually removed a few features from the actual data structure itself as it is internally. It involves hashing, so and there's some other features that we take away from the user, and it happens in the background, but it's a data structure. It's all in memory. So in this case, we're putting something there. Oh, whoops. We have at least this integer there. Get integer, set integer, we're checking for that integer up there and down there. So we have at least an integer in there, which isn't very much data, right? Most modern RAM chips can easily handle one more integer, but most of our games are going to have more than just one integer we want to keep track of, right? So I wanted to point out the thing about that is it's essentially like a what we would call a dictionary in Python, only it's entirely in machine language. It's hashed, and really direct access to it is better through assembly language. But you can think of it like a dictionary, a place to store stuff, which means that stuff is always going to be stored in RAM, not in long-term storage. So that works for small bits of storage, but keep in mind that if you start to have lots of data that you want to keep track of, big complicated role-playing games, some D&D sort of game springs to mind because your character builds up over time, right? People that play D&D for a while, they might end up with several pages in traditional D&D, they might end up with several pages in a notebook of their character's evolution over time, which can add up to a lot of data. And if that all has to be loaded into memory the whole time your game's running, that's using up memory that we could be using for other stuff in more interesting situations. So the main thing about that is that one's always available. It gives us small bits of storage, but keep in mind, you want to keep that small. If it starts to grow at all, you probably want to switch over to writing an actual file in storage, because retrieving, it has to get really, really big before we have to worry about retrieval times from storage affecting things in our modern world. And most of our systems are SSDs, so there's not really any time component there at all. So I just wanted to make sure and point that out, because our textbook just goes ahead and uses that in all the games it does. But keep in mind that does use memory the entire time your game's running. So if you just have a couple integers, like a high score that you want to compare things against, that's not much memory at all. But if you have lots of data, like all of the stats for your player and stuff, you might want to start to consider using a normal file that you can retrieve that data from. Something structured, JSON, XML, something with a structure that you can retrieve the data quickly. SQLite database, if it gets really, really complicated and is very nicely structured. And that way you can dedicate more of your memory to the game processes itself. Because usually if you have that stuff, your game is doing, you have a big complicated game, right? If you have to start worrying about how much data you're actually storing, you have some interesting stuff going on in your game. So you probably need that RAM for processing, not for storing arbitrary values that we could retrieve from formal long-term storage if needed. Small stuff and player preferences, big stuff in files is the note I had. So that was most of those notes, the things I wanted to talk about, just little tips along the way. The book covers a lot of it, but our book doesn't have everything. So another thing I wanted to, that I think is really nice, especially in role-playing games, is we might want to use our buttons for different things. I think everybody's aware of this. Quite often, well, our first game had us use the mouse to move the player object. The second game, the one this week, I'm assuming y'all have done this too, or have at least looked at it. But if you haven't, it's using the normal keyboard controls, WASD or the arrows. They both work. If we use the input manager instead of actually manually checking for keys, which is another thing probably should have put on my list here, is you always want to use the input manager. I think that was on my list of changes as I worked through the book this week. Oh, yes. So when they did the space bar to fire, they manually checked to make sure that the space bar was, that it was the space bar that was pressed, which I guess is good to see that syntax. But under edit and preferences, did I go to the wrong spot? Oh, I'm at project settings. Edit and project settings. And I tend to click on those, the wrong one of those all the time. See the input manager, and that input manager has things called axes, which that name makes sense with the horizontal and vertical axes. Our A and D keys, as well as the left and right arrows, both have the same function. But if I stuck in a plug and play controller, it would have a switch to the different ones. So you always want to use the axes, which that name sounds weird, but you might recall that when we were talking about vectors, I mentioned very briefly, at least very briefly in passing, that axes is a synonym for dimensions. Let me grab something from here. So here's a little controller project I've been working on. Nothing fancy for it straight on, but I wanted a spinny thing and a slidey thing included as well. I think right now it has Arduino code, but once it works, I will get rid of the easy to work with Arduino stuff and just flash that on as a random, as an HID report, which is the plug and play. So that chip won't think it's an Arduino anymore. It'll just think it's it just sends a report to the computer, and that report comes in as a vector. So all the buttons on your controller and the keyboard, the mouse, and all of that stuff is actually coming to the computer as a vector. Yes. So the chat room, there was a comment about the axis and axes. So yeah, it's the plural form. Axes, AXES, is plural for both the tool for chopping up wood, as well as the plural for AXIS, which is a synonym for a dimension in a vector. So our keyboard address or our plug and play controllers, those come in, all the values from that come in as one vector. So no matter what type of controller we have, if we use the input manager, we can do that. So instead of, so when I modified that, instead of manually checking for the space bar, I use the jump axis, which is exactly the same if we're on a computer. But if we plug up an Xbox controller, that's very different, right? There is no space bar on the Xbox controller or the PlayStation controller or any other generic type of controller. The little controller I just grabbed here, it's definitely not a space bar on there. I put a whole lot of things on there, but not a space bar. So whenever those send the reports, which the reason I used an Arduino there was for the analog digital converter, because I have that part, and then the chip can just be flashed with any other instructions and goes a whole lot faster when it has other instructions on it, because the clock can just be unsoldered and a faster clock soldered on there. But it still has that really nice analog to digital converter built into it. Makes it easy to work with. But we plug those in, we get a bunch of it sends a vector all at once. It builds up a vector of the state of the buttons. There is a standard. I think the current standard has to do it at least 115,000 times a second to count as a game controller. That's like the bare minimum. So most of them have to do a lot faster than that. That it sends the state of the buttons as one vector. So when we use the input manager, instead of checking for a particular key, we get a lot more control over that. Yeah, I think that was all I was going to say about that point for now. So I did switch. That was one thing I switched in the instructions. We looked at multiple scenes, talked about singletons. Oh yes, the get component. I wrote that down somewhere, but apparently not in the right spot. It's not on this list. So one more thing with the code. If I pull up any of these have it. I think everything we've done so far has it somewhere. Oh, nope. Apparently opened one that did not have that. Oh, but that's a great version of it. Instantiate game object. Looks an awful lot like our get component thing. Oh, there it is, get component. We've seen that over and over and over again. Get component, and we want the rigid body component. So this is something you all are surely aware of at this point. So I wanted to explicitly state it. I'll go over to the other scene where there's more stuff going on. So in the dragon object here, there's all these different components we can get: the rigid body, the transform, including the dragon script, or in this week's homework, the bounds check script. So what we're really doing there is we're just instantiating an object. So C#, much like Java, you probably noticed, kind of restricts us to one class per file. And that class really should have the same name as the file. We can kind of get around that as long as the first class we put in here matches the name of the file. We could put some other ones afterwards, or nested classes obviously have to go here. A nested class inside of this obviously has to go in this file. But we're kind of restricted to one file per object. So since we're in C#, when we attach that script as a component here, what we're really attaching is that one object that is in that script. So if you take this elsewhere where you're not necessarily where you don't have that restriction, in particular, Python and C++, it's very common in Python that we just go ahead and put all of our classes in one file and just import that thing as a big library, which that's what you want to do to mimic a singleton in Python. The thing that's not class notation, you just put a bunch of variables there. There's still technically methods because we can import that and it becomes an object. But when we do that, we only have one and can only ever have one of them. So things we don't want to duplicate, like a singleton, is the most improved version of that, would just be the non-class notation for objects in Python. But C#, and that is a Unity specific thing. When we have to call that get component, or anytime we're working with components, it's probably already figured out that if we have a get component, we also have a set component, so we can change that dynamically in our code. Whatever our type is, when we call that, it's actually instantiating an object. It's most akin to factories in Java. Anybody use factories in Java? Basically, it's an alternative to a constructor. Instead of writing a constructor for every single item, every single object we need, we set up a factory, and the short version of it is, instead of creating an object, a very special thing that we keep around, a factory can create a whole bunch of disposable objects very quickly. So that's what we're doing when we say get component. It's not like if we called the constructor from that object, because you probably noticed we didn't put any constructors in. We haven't put any constructors in any of our code yet, right? So we can't just automatically create that. We haven't been using constructors, at least not for the textbook or in-class examples. If you've done some other stuff in C#, you might have built a constructor. They look exactly like the Java constructors. So this is kind of akin to the factories in Java, where instead of making that one special object that we keep around and manage carefully and keep track of, we just spit out a whole bunch of disposable objects. We create a disposable one, use it for the purpose we need, and then throw it away. And then the next time we need something from it, we quickly create a disposable one, call the method from it we want, then throw it away. So that's what's really happening here. It's like the factories, which we don't really have in Python and C++. So for those, we just instantiate an object. Instantiate an object. Then delete it. Then delete it, and I'll use Python notation. Garbage collector.collect. So it's akin to doing this every time we want to call a method in Python. We make a new instance of that object, call the one method we want to call from it, method, run that, then we delete that object and immediately tell garbage collection we have something to get rid of. So as soon as we're done with it, we delete it and call garbage collection. That's what factories and the get component is essentially doing. So it's much, much better in memory. We're not wasting memory, which in games we might want, right? It's still very easy to make a game to burn through all the memory we have available, even if they're not available, which I showed in another class. So before we take off for break, I'm going to point out this. About 2 weeks before the first 8-week term ended or so, I don't forgot exactly what day it was. My PC computer broke and I had an important meeting first thing in the morning with some people from Intel. So I had to get another PC because yeah, I didn't want to meet with people Intel using the Mac or the Chromebook for reasons that should seem somewhat obvious. So I had to get a new PC before 8 o'clock in the morning. Ran over to Walmart because I treat hardware as disposable. So I always use the cheapest versions I can get. Like, well, Chromebooks are always cheap, but that's not the cheap. I didn't go with the cheapest Chromebook. I did take a couple steps up from that. But I really like my Chromebook. Some people complain about them, but I've been very happy with that machine. The Mac, the only reason I have my MacBook is there was a scuff mark on the case for it. And Walmart put it on the clearance rack for $300 off because of a little bitty scuff mark. I was like, it wasn't really in my budget, but I couldn't pass up $300 off a brand new MacBook. It's like, that's kind of hard to pass up. So I guess a reminder to check clearance racks, but I treat hardware as disposable. So I'm usually using the cheapest one at Walmart. So this PC here right now is the cheapest PC they sold had at Walmart at 6 o'clock the morning after mine broke. So the cheapest laptop from a store known for selling generic stuff. If I come in here in system, and if we look at these numbers, this is the cheapest at Walmart right now, right? 3 gigahertz and 8 gigabytes of RAM. So we don't have to worry about being efficient like we used to, but there are still plenty of things we could do to run through all of that, right? There are some very, very interesting things we could do. So hopefully all that made sense as far as generalizing the things in the book, because this class is not Unity and C#. Those aren't anywhere in the names of this course. This is game development. So we want to make sure that these concepts apply when we're in Java and Python and C++. Yeah, we looked briefly, talked about the packaging and the manifest, and in Python and C++, we would definitely have to deal with that ourselves. A lot of the ones for Java are automated, but we'd have to choose which one we'd want and set up the automation, whereas it's just built in Unity. But hopefully that generalizes some of the concepts we're seeing here. Now, I want to take a few minutes periodically throughout the semester and make sure that's generalized, so that if you decide you'd rather work in the Unreal Engine and do your coding in C++, the concepts we study here still make sense. Then all I have to do is change to the other language. Or work with JMonkey, that's kind of a nice one that works in Java. Or if you just get tired of it and want to write code in Python for a while and deal with some nice, easy coding situations when the Python language will be in the disadvantages that come with Python won't impact your game. It's like, yeah, I'm going to go with the easy coding this time. How all of the same concepts still apply. Make sure we're studying game development in general, not just studying Unity. Okay, so that brings us to 7:15, which before classes moved to 8 weeks, that was, all of them were hour and 15-minute classes. So that always seems like a good time to take a break. Does 10 minutes sound good to everybody? Or anybody?
Yep.
Okay, so 7:15, we'll get back to it at 7:25. And the example I pulled up, wanting to look at something neat that's not in the textbook, I'm thinking we'll do a NavMeshAgent, because that's a really nice way to have our character move around. We let the character figure out its own way around the game, and then our buttons can be used for other stuff. So I'll see y'all in a moment.